All right, everyone, welcome to another episode of Mechanisms and Mentorship with your host, Rafael Testai. Today we have a very special guest, Colin Foster. He's the founder of a company called Solid Design and Detail, and they specialize in doing design and detailing that focuses on modeling and drafting using primarily SolidWorks, our loved software CAD package. Here in the background, we have one of his first projects, which is a boat used for special forces with stealth capabilities. So, Colin, welcome to the show.
Thanks for having me.
Why don't you tell us a little bit more about this project if you want to click play so the audience can see what is this boat? So we have the big picture. And what did you do in this project?
So this is a CCM MK1 or Mark 1 for SOCOM. And I worked at the company that competed for the contract. And there was 6 other companies competing from the beginning, and it got whittled down to us and one other competitor. And some of the, I can't go into too much detail, but some of the systems that I worked on it were key reasons that we won the contract. After that, I went and started my own company, and my first project was to come back and help them finish this one out.
Beautiful. Well, this actually took a turn. I wasn't expecting to ask him this, so if I catch you off guard, my apologies. But a normal conversation flows like it's about to flow now. So you're competing with six other people. What is it about you and your company that helped you stand out and get this client?
I think it was just being eager to please and do the right things, and just always trying to provide value and doing the best that I can, doing the best designs that I can. The SolidWorks really helps with the 3D modeling to be able to, solve a lot of spatial issues where parts are sharing time and space. And I think that's very, it helped a lot. It helped being able to, see where certain things were going to bind and things like that.
So this is a little out of the ordinary. We usually have mechanical design engineers show us products that they do that are relatively small, something that you can fit like in a shoebox about that size. But Colin has worked on something much bigger. So Colin, why don't you tell us about this project that you worked on here? If you want to click play, so we have the big picture of what it is. And then he'll dive into the CAD.
So this is the Mud Mountain Fish Bypass Facility. It's the largest fish bypass facility in North America. They were moving 30,000 fish per day or per year, and now they're moving that every day through this system. It's up in Washington, and what happens is the fish come in, and then they get pushed into a pool, and then a crowder comes in and pushes them into this Archimedes screw that takes them up and then sorts them out by native or hatchery fish. And then the tribes can come pick up their fish, and then we can move the rest of the fish up the river. This will get into it.
So this is something that I've never heard a designer work on, which is making something that can filter fish, if I'm correct, right?
Yeah, and it moves them above the dam to reduce fatalities.
Okay.
So the fish don't have to go through the dam; they can go around it. So from here on, is pretty much the rest of it's me. This is where my scope started.
These doors, everything?
Yeah. So these let the fish in. When they're closed, the fish can't get in. Once they open, then it'll let them in. There's some bulkheads back here that can stack on top of each other that are pretty cool. But then that lets them into like the crowding pool, and that is this part. And so these things have 2 different screens on them, and one screen pushes the fish in, and one scrape pulls them out so they can clear it out. Here you can see it in action. So that'll push it up to a little flipper that'll then push the fish into this Archimedes screw that'll ladder them up and then shoot them down these chutes right here.
Oh, there's the Archimedes screw. Okay.
Yeah. And so that's the first fish to come through.
All right.
That was number 1 fish. And so inside, in the flumes, they also have scanners that scan the fish to tell if they're native or not, and it has an actuated flipper that'll sort the fish depending on if they're native or not. pretty cool.
How does it scan the fish?
They have tags on them.
Okay.
So hatchery fish will have tags on them.
Very cool. So why don't you show us the CAD that you worked on?
All right.
So we can dive into some of these details.
So here's like an overview of the system.
Okay. So you told me before we started shooting that you have to hide some things. Why don't you explain us the big picture of what's supposed to be hidden so we can understand what's happening here?
Yeah, no problem. So obviously I didn't go and model all of the tubing in between the chutes, but here you can see the chutes in their positions.
So this is where the fish was passing through in the video, right?
Yeah.
Okay, great.
And so these flippers will sort them depending on where they need to go. And then they'll end up down here if they're going one place, and they'll end up down there if they're going to another. But then coming into it over here, here's that section I was showing with the gates that let the fish in. And so these crowders here will push the fish. This crowder can drop down on the way back, so if it's pulling them back, this one will be down. And then this one will be down if it's pushing them towards the crowd or towards the screw.
So you designed all this based on the customer requirements?
Yeah, so a lot of my work's done off of engineering drawings. I don't do the engineering. I outsource engineering if I need it. My work starts after the engineer and in between the engineer and the fabricator. So I kind of bridge that gap for them.
Okay, so the customer gives you drawings that you need to turn into models, is that right?
Yeah, like 90% of the time. Sometimes we do design builds, but
Interesting, because I'm more on the engineering side here at Pipeline Design and Engineering, where we're shooting this right now in this beautiful podcast room. And we usually do the design and then we give the drawings to the customer. My question would be, how do you have drawings if somebody didn't create CAD before the drawing?
so they create CAD, especially the structural guys. They'll create a rough model, but it's not enough to give to a welder and have them build from, if that makes sense. So I'll take it down to the actual part details. So every part has a drawing that knows exactly what needs to be done to it to take it into the weldment, and then that'll have drawings to show like what welds go where, what machining needs to happen, all that kind of stuff.
I see. So if I understand correctly, you get this package of drawings that had CAD that made the drawing, but then they're not drawings that are ready for manufacturing yet. You need to add details to it.
Exactly, yeah.
Okay. All right. What's an example of that? Can we show that?
Yeah.
Yeah.
I'll load some up. So these are the drawings from the U.S. Army Corps of Engineers, and this is an example of what an engineer would produce. It has all the required information that you need to contractually describe it, but it doesn't have enough information to go through and have the welders actually build from these drawings. It's just kind of overall dimensions a lot of the time and telling you what kind of material is each part. But they're not going to give you like the dimensions of each plate and like what hole size to cut everything and where to notch certain parts so that they don't interfere with other parts and all these other things that it takes to actually build a project.
This is a little bit of mind-blowing to me. If they took all the time to make all the CAD in this monumental assembly here, why didn't they share that information that you just described?
They can. It's just not good. It's not generally good enough for like a fabrication quality, if that makes sense. Especially, I mean, in mechanical it probably is more close, but in structural it just kind of exists. It doesn't really have the fine-tuned data that you need to actually fabricate something.
Okay, so you have this drawing that they give you, and you said that you're in an industry called structural. Is that right?
Yeah,
That's
so like structural engineering.
Structural engineering. So then what is all these yellow marks? What's happening here?
That's me checking my design to their design.
What do you mean by checking your design to their design?
So as I build my models and drawings, I have to make sure that my design conforms to what the engineer specified. That's where my liability lies.
Okay, perfect. So after you were given, if we go a step back, you were given that drawing that had the missing holes, dimensions. What do you do next after you receive that first drawing?
I'll go through and I'll start looking for easy to identify items that I need more information on to write RFIs, so that I can at least get that ball in the engineer's court, to hopefully start generating some answers to get back. In the meantime, I'll start proceeding with my model with the information provided.
So I guess one of your real skill sets is that you can see something in 2D in a drawing and convert it into CAD from looking at it. Okay.
Yeah. Yeah.
You're bringing it to life. You're bringing a drawing to life.
Yeah.
Okay.
See, it's like these have a lot of information on them, but it's not perfect, right? It's not going to tell you exactly what hole sizes and locations that things need to be. Like, they'll just specify a generic screen, and then I have to go find one and make it work. And there's a lot of just finessing the stuff. Like, look at this one. This is all the missing information on this one.
And we're not criticizing by all means. What we're doing is we're giving you an
Yes.
insight into the industry and the difficulties that you may encounter and how to overcome them.
It's an opportunity for us to solve problems. Because you can't expect the engineers to go into this much depth, or they'll never get anything done anyways. So it's a team effort. But so that's like the drawing package for this, and then this is my drawing package. There's probably like 30 sheets in this package alone. But
30 sheets in a drawing. I've seen 8, 10 max. Usually it's like 3. Well, that's substantial.
I just submitted one last week that had like 80 something, and it was just for a platform. But here you can see it just goes into a lot more detail. This is something you could hand to a welder or somebody on the shop floor. They could go build this and not even know what it goes to.
Okay. So I guess you're pretty good at GD&T.
Yeah, it comes with the territory.
Okay. So one time you and I were talking and you were telling me that, sometimes people don't like to do drawings, but you said something along the lines of that's where the money's made or something like that, right?
Yeah, that's really the end product a lot of the times, at least for now, until things change and everyone embraces iPads on the shop floor. Where we're at now, the drawings are what they're using to actually make it. The models are more there to help give them an idea, visualize the project, but they're not. And this is obviously, times are changing, but generally, people don't have iPads on the shop floor to be able to look at the model.
The deliverable is the drawing. It's like the binding contractual agreement.
Yeah.
So you're talking about times changing. Again, we didn't schedule this, but it's going with the flow of the conversation. What do you see as times changing? What are we getting away from and getting towards?
I think we're going more electronic. Everything is. I still think there's value in drawings, but I think it might be pushed more towards what do they call it, where it's actually detailed in the model part itself.
There's a term for that, and if anyone knows, please leave it in the comments. I heard it before, but I forgot at the moment. But yeah, you can click on the CAD and it'll tell you the exact dimensions, the tolerances. Okay.
I think that's coming, but I think there's a learning curve to it, because you're going to have to require people to have at least a basic understanding of SolidWorks when they're working on the shop floor versus. I think there'll be a little bit of a learning curve with that, but I do think it's the right way to go.
Okay. Have you seen any company actually implementing that?
I haven't yet, but I've read about them online.
Yeah. Who have you heard about online?
I don't know. I don't remember names off the top of my head, but
I think isn't Tesla?
Are they?
Yeah, to my understanding. Colin's a huge Tesla fan, from my understanding, aren't you?
I like it.
Yeah.
Yeah, they've won me over, being a traditional car guy my whole life, and it's pretty wild how fast they are.
What is it about Tesla that just won you over?
I really like Elon. He's always been like a role model of mine. But I remember as a kid playing with like remote control cars and slot cars, and they were just insanely fast. And me and my brother were always like, man, if they could ever figure out how to do this in a real car, wow. And it's like, no wonder. It's like there's no emissions to them except for like the battery creating process or whatever, but we're working on that. but there's like no maintenance at all. I've had the car for a year, and I've had to put window washer fluid in it.
Right on. All right, let's see. What's like maybe another project, or is there something else you may want to share about this project before we move on to the next?
I can just go through the model real quick.
Okay, let's do that. So now Colin's going to show us that 2D drawing that we were looking at before. What does that look like on CAD? And maybe some things you want to highlight that share with us.
All right. So the drawing that we were looking at is this piece of equipment here called the Crowder. It's that guy. One of the things I love about SolidWorks is there's companies that make software for detailing, steel detailing, which is what I primarily do.
So for the final part of the first video we're doing today, we're going to show how Colin has worked in aerospace in projects that involve rockets. It's called GSE, Ground Support Equipment. So he's not actually designing the rockets, he designed the equipment that supports the rocket. Is that right?
Yep.
So why don't you show us like a little video and then show us what you designed?
So this one I did while I was still an employee, but I figured it was cool to show just to give people an idea of the kind of projects that they can work on. They designed the whole tower, but my part was the crew access arm. And so here's a quick...
Is it this up here?
So they did the whole tower, but that's my arm.
Oh, that's the arm that he designed.
And so that is the last piece of Earth that our astronauts will touch before they get flung into space.
That could be the title of the video. That's very cool. That's out of this world.
Thank you.
All right. Well, why don't you show us maybe a little bit of the CAD and how you designed that?
All right. So this is a different company. This is one that I've done in the business, and this is a shipping fixture for one of the companies that I work for.
So still aerospace, but different project. It's not the
Yeah.
arm anymore. Okay.
Right. Yeah. But this is so it's to ship a piece of the rocket itself. But yeah, it's pretty intricate. I mean, it's got a lot of mechanical components in here and structural.
And you made this based on drawings that you were given, right?
So this is a design build project. There was no engineer drawings on this. I worked one of my favorite clients is an engineer, and he does a lot of this stuff, and we work together on these things to develop drawings for him. So he'll stamp my drawings.
Okay. And were you involved in designing this, or did the whole design? Okay.
Yeah, we have weekly design meetings on all these projects.
Is there a cool mechanism that you may want to show us here?
So this is where the rocket mounts to on this ring. This is the transport ring, so that's how they move the rocket around. It drops into this trunnion here.
Just to get us an idea, sorry to interrupt, but how big is this, what we're looking at right now?
Yeah, 16 feet length on this so
All right. Just
pretty good size.
So the rocket is transported using this, correct?
Yeah, so they put this on the back of a bed. They'll be able to lift it off of it. So this piece is attached to the rocket in transport, the ring. That's what they will move it with. And then they set it in these cradles, and they hinge down here to accommodate movement and all that stuff. And then once they get it in, then they can strap it down and secure it for transport.
Do we happen to have a similar picture from Google Images or something showing the rocket actually being in here, being transported by any chance?
Basically, everything in black on this is stuff that I did. There's my shipping fixture right there.
This black one?
Yep.
Since we're talking about Sam, let's give a little bit about the story of the logo of your company and how that happened.
Yeah. So I made it in SolidWorks. I knew what I wanted it to look like, and I figured the best way to do that was to model the cube, and then and put the S and the D on there as extrusions.
Okay.
And then I created a SolidWorks drawing view of that at 45-degree ISO. And then I used that for my line work for it. And then Samantha worked in printing at the time, and so she helped me pick out complementary colors that are scientifically appealing.
Women are just a perfect complement for men. Congratulations. What a great team.
Thank you. Don't burn any bridges. you never know what relationships will take you places, and just be eager to help people and be useful. And if you're constantly looking to provide value, then people like this will find you eventually. It's just a matter of time.
That's a perfect segue onto video number 2 that we're going to shoot. That we're going to talk about Colin's story. He's self-made. We're going to talk about where he went to college, the niche market that he found, where he feels like there's still a lot of work out there and a lot of people can make money doing what he does. And he actually wants to grow his team, if I'm not mistaken. You're in the process. So we're all going to talk about that in the second video. If you like this video, like, comment, subscribe to me, Rafael Testai, on the SolidWorks blog. Like it. And stay tuned because video number 2 is coming here below.